So the problem is that in a parallel universe, there are some problem IDs are given and the order of the problem IDs are like this. So the first problem is A, the second problem is B, and so on, and the 26th problem is Z, 27th problem is AA, 28th problem is AB, and so on. So that how the sequence goes on. So the problem is that you are given a particular problem ID and you have to find out the number of that problem ID. Find out the number of that problem ID, right? So an example will be, suppose you are given AB, then the answer is 28 because AB is the 28th problem ID. So let's try to understand the problem with a particular example. So suppose the example is EDBC and you have to find out the number of that particular ID, right? So one thing to observe here is that your EDBC will lie between 4A's to 4Z, right? Because the length of this string is 4 and the smallest string that can be possible with length 4 is 4A's and the largest string that can be possible is 4Z. So EDBC will obviously lie between 4A's and 4Z. So your EDBC will lie between 4A's and 4Z's. So the total range from A to EDBC can be divided into two parts. One is from A to 3Z's, which is the first part, and the second part is from 4A's to EDBC, right? And the sum of those two parts will give us the ID number of EDBC. So we can write the ID number of EDBC is nothing but the number of strings from A to triple Z plus the number of strings from 4A's to EDBC. So let's calculate the first part, which is from A to triple Z. This part actually. So if we consider this part, so from first let's calculate from A to Z. So there can be 26 possibilities here, right? And then calculate from AA to ZZ. So there are actually two positions and each of these two positions can be filled with one of the 26 letters. So the possible number of strings is 26 multiplied by 26. And the third range is AAA to ZZZ. And there are three positions here and each of those three positions can be filled with one of the 26 letters. So the number of possibilities are 26 multiplied by 26 multiplied by 26. So the total number of strings that can be possible from A to triple Z is nothing but 26 plus 26 square plus 26 to the power 3. So the first part can be written as 26 to the power 1 plus 26 to the power 2 plus 26 to the power 3. Here, look at this, that the length of the string is 4 and the last power of the 26 is length of that string minus 1. So for any particular string, the generalized formula is nothing but 26 to the power 1 plus 26 to the power 2 plus 26 to the power string length minus 1. So let's calculate the second part. For calculating the second part, the first step which we will take, we will only change the first letter, right? We want to make the first letter E from A, right? And rest of that letter will remain as it was. So actually we want to reach a string something like this, right? Here we can see that the first letter has only been changed and the rest of the letters are remain as it was, right? So we want to calculate the number of strings before this E triple A, right? So the number of the string before E triple A is nothing but D triple Z, right? So actually we want to calculate the number of strings from 4S to D triple Z. So to calculate this part, let's first calculate 4s to A triple Z. Here you can see that this particular A, which is in the first position, will remain as it is, but the next three letters will change from triple A to triple Z. That means on those three positions, any letter can be a possibility, because we are traversing from the smallest letter to the largest letter that can be possible of length 3, right? So the total number of possible strings from 4s to A triple Z is nothing but 26 to the power 3, right? So if we want to calculate B triple A to B triple Z, which will be again 26 to the power 3, and then if we want to calculate C triple A to C triple Z, this will be again 26 to the power 3, and D triple A to D triple Z, it will be again 26 to the power 3, right? So if we want to calculate the number of strings from 4A's to D triple Z, then the total number of strings is 26 to the power 3 multiplied by 4. So one thing here to be noted is, we are saying that we are changing the first letter A into a E, right? And we want to find out the total number of strings. But on that particular range, we are not considering E triple A, right? E triple A is not present in this range. So we are just calculating the number of strings just before E triple A, right? Which is D triple Z, right? So we are calculating from 4A's to D triple Z, which is just before E triple A. This E triple A will be considered in the next consideration, or when we are calculating the next range. So now let's change the second letter. The second letter which we need is D, right? And we have E triple A, right? We have reached till E triple A, right? So we want to change this A to this D, right? So what we want to reach is something like that, right? We will just change the second letter, which will be altered into D, and the rest of the letters will be as it was, right? And now we want to calculate the number of strings that are possible between E triple A to E D double A, right? We want to calculate the total number of strings on that range. As in the previous calculation, we have seen that as we wanted to calculate from 4A's to E triple A, we ended up calculating from 4A's to the string just before E triple A, right? So in this segment also, when we want to calculate actually from E triple A to E D double A, actually we will calculate the total number of strings from E triple A to the string that appear just before E D double A, which is nothing but ECZZ, and this ED double A will be left out, as E triple A was left out in the previous segment, right? So we will actually calculate from this range to this range, and here you can see the E triple A that was left out in the previous segment will be now considered in this segment, right? So we will consider this E triple A in this segment. So let's first calculate from E triple A to EA ZZ, right? So here you can see that the first two letters will remain as it is, but the next two letters will change from the smallest to the largest. That means all possible combinations will appear, right? So the total number of strings that can be possible for two positions is 26 to the power 2. So the next string after EA double Z is nothing but EBAA, and we want to calculate from EBAA to EBZZ, which will be again 26 to the power 2, and the string after EBZZ is nothing but ECAA, and the and the last string is ECZZ, and here again the total number of possibility is nothing but 26 to the power 2, right? So we can say that from EAAA to ECZZ, which is just before EDAA, will be nothing but 26 to the power 2 multiplied by 3, right? So actually we wanted to go from EAAA to EDAA, but we end up by going from EAAA to the string just before ECZZ, right? And this EDAA, which has been left out, will be actually considered in the next range when we calculate. So by looking at these two segments, we can observe a little bit more. We can see here that in the first segment, we wanted to change the first letter. The first letter was A and we wanted to change it to E. E is the fifth letter in the alphabets and A is the first letter, right? And 5 minus 1 is equal to 4, which is here. In the second segment also, we wanted to change the second letter. The second letter was A and we wanted to change it to D. D is the fourth letter in the alphabet and A is the first letter. So 4 minus 1 is equal to 3. 3 appears here, right? So if we want to change any letter, the multiplication factor that will be multiplied by 26 to the power something is nothing but the subtraction between the order of those two letters. Again, if you observe a little bit more, for this particular segment, we consider 26 to the power 3, and for this particular segment, we consider 26 to the power 2, right? So why is that? Because on this particular segment, we considered changing the first letter. So the length of the string was 4 and we want to change the first letter. So 4 minus 1 is equal to 3. So that's why here it is 26 to the power 3. In the second segment, we wanted to change the second letter, which was A, and we wanted to change it to D. So the length of the string is 4 and we want to change the second letter. So 4 minus 2 is equal to 4. 4 minus 2 is equal to 2. That's why we have written 26 to the power 2. So we can say that if you want to change any letter, then the power factor, which will be the power of 26, is nothing but the length of the string minus the position of that particular letter. So we can say that the formula is 26 to the power length of the string minus position of the letter, and this whole thing will be multiplied by position of the required letter in the alphabets, right? So if suppose you want to change the letter into Z, then it will be 26. If you want to change the letter into Y, then it will be 25. So such that, so position of the required letter in alphabets minus position of A, because each time you are changing A into some letter, right? And we can also say that that position of A is nothing but 1 because A is the first letter in the alphabet. So we can write it like that, that position of the required letter in the alphabets minus 1. So till now we have been able to match two letters, first two letters, which is ED and ED, right? So let's move on to the third letter. We want to make this particular A into B. So what we will do, we will only change this A to B and rest of the letters will be remain as it is. So actually we are looking a letter, a string, something like this, which is E, D, E, D, B, A, right? B, A. Only this particular letter have been changed into B, right? So we want to calculate the total number of strings between EDAA to EDBA. So actually we want to calculate the number of strings just before EDBA, and this EDBA will be considered in the next segment, right? So the string just before EDBA is nothing but EDAZ, right? Because after EDAZ, EDBA will be appeared, right? So we want to actually calculate the total number of strings on this range, right? And if we just use our formula, then we can write the total is nothing but 26 to the power, length of the string is 4 and the position of the letter is 3. So 4 minus 3 is equal to 1, and this whole thing will be multiplied by position of the required letter. So position of the required letter is B minus 1. So B is the second letter. So 2 minus 1 is equal to 1. So which will be eventually 1, right? So actually it is 26, right? Here you can also see the total number of strings between EDAA to EDAZ is actually 26, right? Because these three letters will remain as it is and it is changing from A to Z. So there can be also 26 there can be only 26 number possible, right? So our this formula is absolutely fine. So now we have reached from EDAA to EDAZ, right? So now we want to find out the total number of strings that can be possible in EDBA, from EDBA to EDBC, right? So till now we have been able to match three letters, which is EDB. Now we want to match this C with this A, right? So if we want to go from A to C, it's very easy, right? Because there can be three strings can be possible from EDBA to EDBC. So first one is EDBA, the second one is EDBB, and the third one is EDBC. So the total number of strings that can be possible is 3, and this 3 is actually nothing but the order of C, right? So when you have reached the last letter, just add the order of the last letter required, right? We require C and the order of C is 3, then you just add 3, right? So if we just put the values of these into the second part, then we will get 26 to the power 3 multiplied by 4 plus 26 to the power 3 multiplied by 3 plus 26 to the power 1 multiplied by 1 plus 3, right? So the ID number of EDBC will be sum of those two parts, right? So the summary is, for any particular problem, this solution can be divided into two parts. For the first part, just add 26 to the power 1 plus 26 to the power 2 plus dot 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 26 to the power string length minus 1. And for the second part, take a for loop and start from the very beginning, and for each of the letter your term will be nothing but 26 to the power length of the string minus position of the letter multiplied by order of that particular letter minus 1. And you have to do this by using a for loop, and whenever you have reached to the final letter, just add the order of the final letter, right? If your final letter is Z, just add 26. If your final letter is Y, just add 25. And the sum of those two parts will give you the ID number of that particular problem. If you find this video helpful, please subscribe to my channel and for getting more contents like this. Thank you.